Digital etiquette. Uh, in the digital etiquette. So in the media equation, Cambridge University Press, 1996. Stanford sociologists Clifford Nast and Byron Reeves make a compelling case that humans treat and respond to computers and other interactive products as if they were people. The implication of this research is profound. If we want users to like our products, we should design them to behave in the same manner as a likable person. If we want users to be productive with their software, we should design it to behave like a supportive human colleague. Design principle: the computer does the work and the person does the thinking. Science fiction writers and computer scientists tantalize us with visions of artificial intelligence, computers that thinks for themselves. However, humans don't really need that much help in thinking department. We do need a lot of help with work of information management, activities like accessing, analyzing, organizing, and visualizing information. But the actual decision made from that information are best made by us, the wetware. So remember, this is written in 2014, so it may not be that accurate as it was said because of ChatGPT. Designing considerate products. However, it's not enough that software treat us as people in the division of labor. Politeness could be construed as a matter of manners and protocol, saying please and thank you, but doing little else that is helpful. Being truly considerate means being concerned with the needs of others, above and beyond performing basic functions. Considerate software has the goals and needs of its users as a concern. So, saying please and thank you doesn't do much to consider us to be considerate. We need to do more than that, such as performing beyond basic functions. So, considerate software has the goals and needs of its users as a concern. If an interactive product is stingy with information, obscure its processes, forces users to hunt around for common functions, and is quick to blame people for its own failings, users are sure to have an unpleasant and unproductive experience, and this will happen no matter how polite and cute your software is. On the other hand, interactions that are respectful, generous, and helpful will go a long way toward creating a positive experience for people using your product, and humans have many wonderful characteristics that make them considerate, and some of these can be emulated to a greater or lesser degree by interactive products we created. We think the following are some of the most important characteristics of considerate interactive products in the next paragraph, and none of these characteristics, by the way, is at odds with more pragmatic goals of functional data processing, which lies at the core of all silicon-enabled products. First, considerate products take an interest. A considerate friend wants to know more about you. He remembers your likes and dislikes so that he can please you in the future. Everyone appreciates being treated according to his or her personal taste. Little, if any, of the personal software on our personal computer seem to remember anything personal about us, in spite of the fact that we use it constantly, repetitively, and exclusively. A good example of this behavior is how browsers such as Firefox and Microsoft Internet Explorer remember information that users routinely enter into forms on websites, such as shipping address or username. Google Chrome even remember these details across devices and sessions. So, a friend or a considerate friend remembers your likes and dislikes so that he can please you in the future. So everyone appreciates that according to being treated according to their mental model or likes and dislikes. So Google Chrome and Microsoft Edge is a good example. So they remember information such as shipping address and usernames. And they also remember these details across devices and sessions of that Windows. Not only are digital products better suited to recording things in memory than humans are, but our products also show they are inconsiderate when they forget. Remembering human actions and preferences is one of the best ways to create a positive experience with a software enabled product. So that the combination of having the software as great in memory because they can remember more than us, uh, it's also inconsiderate to forget those likes and dislikes. So remembering human actions and preference is one of the best way to create a positive experience with software-enabled product. Software should work hard to remember our habits and particularly everything we tell it. So everything that we tell the customer or the software should be remembered or should be recorded. That's why the data analytics tool are there to be that are always there on these technologies. Considerate products are differential. Another thing with this interest is that most technologies today has this data analytics integrated to it. So that's actually how the data analyst jobs has been created. Considerate products are differential. A good service provider differs to her client. Software can suggest that we not submit our entry until we've typed in our telephone number. And it should explain the consequences if we do so. But if you want to submit without the number, we expect the software to do so as is told. Software should submit to its users. So, like a waiter that could suggest things by providing an option of the table, we are still in command. If the waiter forces us to that table, we will sure find another restaurant. So it's the same with this differential characteristics. So they can only suggest it, but we are still the last decision maker. And then yeah, they should explain the consequences if we do so. So later we will gonna see why some of that could um, there could be some reason, especially for modern software, for providing this warning, such as suggestion of not to submit things. So considerate products are forthcoming. If you are a good retail sales associate for help locating at an item, he will not only answer your question, he might tell you that a more expensive, higher quality item than the one you requested is currently on sale for a similar price. Unlike YouTube that provide related videos in our feeds, most software narrowly answers the precise questions we ask it and typically is not forthcoming about other information, even if it's clearly related to our goals. So you need to provide this related information that is unknown to your user because in the previous book, remember, solving problem or the customer are not aware of the choices that they have. So you also need to know the customer, which we will later dig deep with the principle of knowing, which we also highly connected with goal-oriented persona as well. So another example is when we tell our word processor to print a document. It doesn't tell us when the paper supply is low or when 40 documents are queued before us or when another nearby printer is free. There's a caveat because Microsoft Assistant that we discussed in previous book that distracted because of its image and the way it knocks its users. Remember, a good waiter doesn't interrupt your conversation to ask you if you want more water. He just refills your glass when it's empty, and he knows better than to linger when it's clear that you're in the middle of an intimate moment. So there is a caveat in providing this related information because like in the Microsoft example in the previous book, that avatar that for woman became like a discrimination and distraction for some users or for most users. So after that first um, notification, it becomes a distracting part. So there's a balance. Considerate products use common sense. Many interactive products put controls for constantly used functions right next to never used controls. Horror stories also bound of customers offended by computer systems that repeatedly send them checks for $0 or bills for $957,000. One would think that the system might alert a human in the accounts receivable or payable departments or when an event like this happens, especially more than once, but common sense remains a rarity in most information systems. So it's like related on don't put the lever seat or seat lever something like that with a fighter jet along with your most common use functions with the in the previous video. Considerate products use discretion, but there are some things that software probably shouldn't remember unless we specifically direct it, such as credit card numbers, tax IDs, bank accounts, and passwords. Furthermore, it should help us protect this kind of private data by helping us choose secure passwords and reporting any possible improprieties such as accounts access from an unrecognized computer or location. So sometimes there is this exception for like an IDs or important information. You need to provide security features um, for this kind of data. You can also provide these anomalies of unrecognized computer or location. Considerate products anticipates people's needs. A web browser spends most of its time idling while we peruse web pages. It could easily anticipate our needs and prepare for them while we are reading. it could use that idle time to preload all the links that are visible. So when it is requesting for some web page that takes time, it can do something in the background, unlike before that it locks your um, screen or window. Chances are good that we will soon ask the browser to examine one or more of those links. It's easy to abort an unwanted request, but it's always time consuming to wait for a request to be filled. So it's better for the web pages, if it's a web application or websites, to preload the needed request, even though it might not the user might not need that later, because it's easy to abort an unwanted request, uh, but it is always time consuming to wait for a request to be filled. We'll discuss more ways for software to use idle time to our advantage later in this chapter. Considerate products are conscientious. A conscientious person has a larger perspective on what it means to perform a task. Instead of just washing the dishes, for example, a conscientious person also wipes down the counters and empties the trash, because those tasks are also related to the larger goal, cleaning up the kitchen. A conscientious person, when drafting a report, also puts a handsome cover page on it and makes enough photocopies for the entire department. So the software knows better, like dishwasher that clean things, anything related to the user goal, or things that could improve the business. Or another example is a drafting report where uh, it also puts a handsome cover page on it and makes enough photocopies for the entire department. So those proactive attitude of the customer of the software that allows it to help the user achieve its goal makes it more considerate, which help us to make the software more usable. If we if we rely on a typical word processor to draft the new sprocket contract and then try to save it in the microblitz folder, the application offers the choice of either overwriting and destroying the old widget contract or not saving it at all. So some application like this offers the choice of overwriting the document and destroying the old widget contract or not saving it at all. The application not only isn't capable as the person who isn't organized and provide those proactive details such as the date of the folder and then the organization of the month of that folder for the bosses to see that he organized it, to make it as less cognitively demanding for the boss. But it isn't capable as that, so that software is dumb enough to assume that because two folders have the same name, we meant to throw away the old one. So just because it has the same name, we meant to throw the old one. The application should at the very least mark the two files with different dates and save two of them. Even if the application refuses to take this drastic action unilaterally, it could be at least show us the old file. Letting us rename that one before saving the new one. So if this is not possible, like marking this with different dates and saving both of them, It could at least show us the old file and then let us rename that before saving the new one instead of overwriting and then vanishing those two files. Considerate products don't burden you with personal problems. So, at a service desk, the agent is expected to mum about her problems while showing interest to their customer. It might not be to be so one sided, but that's the nature of service business. Because computers don't have egos or tender sensibilities, they should be perfect in this role, but they typically behave the opposite way. Software whines at us with error message, interrupt us with confirmation dialog boxes, and brag to us with unnecessary notifiers, document successfully saved. How nice for you, Mr. App. Do you ever unsuccessfully save? We aren't interested in the application's crisis of confidence about whether to purge its recycle bin. So we've discussed this in mistaking the probability to possibility. We should have a good enough judgment to predict that it is the probable step. So we don't want to hear it whining about being unsure where to put a file on a disk. We don't need to see information about the computer's data transfer rates and its loading sequence any more than we need information about the customer's agent's unhappy love affair. So we don't need to know the implementation model because it just confuses us and it's not related to our goal, just as discussed in the previous video. Considerate products keep you informed. We don't want our local bartender to grouse to us about his recent divorce, but we appreciate it when he posts his prices in plain sight and when he writes what time the pregame party begins on his chalkboard, along with who's playing and the current Vegas spread. Nobody interrupts us to tell us this information. It is there in plain view whenever we need it. Software, similarly, can provide us with this kind of rich, modeless feedback about what is going on. So it provides you this update, even though this bartender is having a divorce. It doesn't care about its personal problems. It keeps us updated. It focuses on us and our context using those rich visual modeless feedback. Considerate products are perceptive. Most of our existing software is not very perceptive because it has a very narrow understanding of the scope of most problems. It may willingly perform difficult work, but only when given the precise command at precisely the correct time. For example, if you ask the inventory query system how many widgets are in stock, it will dutifully ask the database and report the number as of the time you ask. So it has a narrow, it's closely related to conscientious and differential. So what if, because this allows the software to provide the right scope with your goals, so it provides additional information that will help you achieve your goals. What if 20 minutes later, someone in Dallas office cleans out the entire stack of widgets? If you want to know about widget once, isn't that a good clue that you probably will know what widgets again? You may not want to hear widget status reports every day for the rest of your life, but maybe you'll want to get them for the rest of the week. Perceptive software observes what users are doing and uses those observations to offer relevant information. So perceptive software observes what users are doing and uses those observations to offer relevant information, just like this. What if 20 minutes later someone in Dallas office cleans out the entire stack of widgets? So if you want to know about widgets once, isn't that a good clue that you probably will want to know about widgets again? So it is predicting what you want. It wants your it is basically making life easier for you, kind of like the persona. We want to know what the customer wants and then predict that and then offer those additional help to minimize the cognitive load. So if we always maximize an application to use the entire available screen, the application should get the idea after a few sessions and always launch in that configuration. So if we are maximizing the application to get the available screen, then the next launch should be remembered. The same goes for placement of palette. Default tools frequently use templates and other useful settings or useful functions. Considerate products are self-confident. If the computer has any suspicion that we might be wrong, which is always, it should anticipate our changing our minds by being prepared to undelete the file upon our request. So it should provide this probability instead of possibility that we have discussed in the previous video. But it must provide an undo to recover with those 20%, because 80% of the time, as we will discover, we only do this specific or most useful task. However, often have you clicked the print button and then gone to get a coffee only to return to find a fearful dialog box quivering in the middle of the screen, asking, "Are you sure you want to print?" This insecurity is infuriating and the antithesis of considerate human behavior. Considerate products don't ask a lot of questions. Asking questions is quite different from providing choices. When browsing on your own in a store, you are presented with choices. Beyond the power dynamics issues, questions also tend to make people feel badgered and harassed. Would you like soup or salad? Salad. Would you like cabbage or spinach? Spinach. Would you like French? Thousand Island or Italian? French. Would you like light or regular? Stop. Please just bring me the soup instead. And then provide the most probable things that I would choose. Would you like corn, chowder, or chicken noodle? So you should not ask a lot of questions. Users really don't like to be asked questions by products. So you should provide choices, especially since most questions are stupid or unnecessary. Asking questions tell users that products are ignorant, it doesn't do its research in our persona, forgetful, not smart, weak, fretful, lacking initiative, or not differential, overly demanding, which is a lot of cognitive load. The application is not asking us our opinion out of intellectual curiosity or a desire to make conversation the way a friend might over dinner. Rather, it is behaving ignorantly while also representing itself as having false authority. So it's not asking out of our opinion, out of intellectual curiosity, but rather it is behaving ignorantly about us and then not remembering our likes and dislikes. So the application isn't interested in our opinions. It requires information. Often information it didn't really need to ask in the first place, because of if it made the proper research, it will have a clue on the probable choice. So many ATMs continually ask users what language they prefer: Spanish, English, or Chinese. This answer is unlikely to change after a person first use. Interactive products that ask fewer questions, provide choices without asking questions, and remember information they have already learned, appear smarter to users, as well as more polite and considerate. Considerate products fail gracefully. For example, say an application is computing merrily along, downloading your email from a server. When it runs out of memory at some procedure buried deep in the application internals, the application, like most desktop software, issues a message that says, in effect, "You are host," and it terminates immediately after you click OK. So it issues a message and then says, "You are a host," and then it deletes all the data while that you are computing or downloading in the email server. So you restart the application or sometimes the whole computer, only to find that the application lost your email. In this example, the application email from the survey server, which then erased its copy, but it didn't ensure that email was properly recorded locally. So it's like in providing undo, but it's not. It's also another considerate principle, which is failing gracefully. If the email application had ensured that those messages were promptly written to the local disk, even before it informed the server that the messages were successfully downloaded, the problem would have never arisen. So if it write that into the disk in the memory stack, even before it informed the server that the message were successfully downloaded, so if that is programmed like that, the problem would never have risen. Some well-designed software products, such as Ableton Live, a brilliant music performance tool, rely on the undo cache to recover from crashes. This is a great example of how products can easily keep track of user behavior. So if some situation causes problems, it's easy to extricate yourself. Even when applications don't crash, inconsiderate behavior is rife, particularly on the web. Users often need to enter information into a set of forms on a page. After filling in 10 or 11 fields, user might click the submit button, and due to some mistake or omission on his part, have the site reject his input and tell him to correct it. So it's still prevalent even today, 2025, especially for government website. So I remember filling up this 10 to 11 fields, and when I go back, it didn't provide me the same input that I made. Also, the tracking for Dole is so hard to remember, because it will only show after you enter the form, and then it will only provide that dialog box in a short period of time without them sending it to your email. So the user then clicks the back arrow to return to the page, and lo, the 10 valid entries were inconsiderately discarded along with the single invalid one. Considerate products know when to bend the rules. In a manual system, when the clerk's friend from the sales force tells him that getting a particular order processed speedily means additional business, the clerk can expedite that one order. When another order comes in with some critical information missing, the clerk still can process it, remembering to acquire and record the information later. This flexibility usually is absent from automated systems. Most computerized systems have only two states: non-existence and full compliance. So it's either full compliance with the form or non-existent form. No intermediate states are recognized or accepted between those forms. So sometimes you just need to provide those partial information, just like what normal data entry clerk would do in real life. Every manual system has an important but paradoxical state, unspoken, undocumented, but widely relied upon. Suspense. So they have this suspense. In this state, a transaction can be accepted even though it is not fully processed. So you accept the transaction and all the information even it's not complete. The human operator creates that state in his head or in his desk or in his back pocket. For example, suppose a digital system both customer and order information before it can post an invoice. Suppose a digital system needs the customer and order information before it can post an invoice. Suppose those are the two parameters that it can be done by the software. That customer and the order information before it can post an invoice, whereas the human clerk can go ahead and post an order before having detailed customer information without having those complete customer information. The computerized system rejects the transaction, unwilling to allow the invoice to be entered without the complete customer information. The characteristics of manual system that lets human perform action out of sequence or before prerequisites. So if even it's not in the normal sequence, such as a complete customer information or before prerequisites are satisfied, is called fudgeability. It is natural result of the implementation model. So developers don't always see a reason to create intermediate states because it's a natural result of the implementation model in the back end. You either have this input, the required input, or not, because the computer has no need for them. Yet there are strong human needs to be able to bend the system slightly. One of the benefits of a fudgeable system is reducing the number of mistakes. By allowing many small temporary mistakes into the system and entrusting humans to correct them before they cause problem downstreams, we can avoid much bigger, more permanent mistakes. So by allowing these small temporary mistakes on the form or incomplete, we could avoid much bigger, more permanent mistakes. Paradoxically, most of the hard-edged rules enforced by computer system are imposed to prevent such mistakes. Because the human is prevented from fudging to prevent big mistakes, he soon stops caring about protecting the software from colossal problems, but the computer system usually ends up having to digest invalid data anyway. So, as a result, the customers stop believing the data and trying to manipulate the system. In real world, Both missing information and extra information that doesn't fit into a standard field are important tools for success. So that's missing and extra are important. For example, suppose a transaction can be completed only if the termination date is extended 2 weeks beyond the official limit. Most companies would rather fudge on the termination date than see $1 million deal go up in smoke. In the real world, limits are fudged all the time. So those extra and um, missing information in real world are actually not is fudgeable or flexible. If it's $1 million deal in business, we could um, override it. So considerate products takes responsibility. In a typical print operation, for example, an application begins sending a 20-page report to the printer and simultaneously display a print process dialog box with a cancel button. If the user quickly realizes that he forgot to make an important change, he clicks the cancel button just as the first page emerges from the printer. So, an application that sends this 20-page report to the printer actually simultaneously show this dialog box with a cancel button. If the user quickly realizes that he forgot to make an important change, he clicks the cancel button just as the first page emerges from the printer. So he could click that dialog box. The issue is that it's just a one-way communication. So the application immediately canceled the print operation. But unbeknownst to the user, while the printer was beginning to work on page 1, the computer had already sent 15 pages to the printer's buffer. Or it already sent the signal. The application cancels the last 5 pages. But the printer doesn't know about the cancellation. It just knows that it was sent 15 pages, so it goes ahead and prints them. Meanwhile, the application smugly tells the user that the function was cancelled. The application lies. User plainly see. The user is unsympathetic to the communication problems between the application and the printer. He doesn't care that the communication are one way. All he knows is that he decided not to print the document before the first page appear in the printer's output tray. He clicked the cancel button and then the stupid application continued printing for 15 pages even after it acknowledged his cancel command. Imagine what his experience would be if the application could properly communicate with the print driver. If the software were smart enough, the print job could easily have been abandoned before the second sheet of paper was wasted. The printer has a cancel function. It's just that the software was built to be lazy to use that cancel function. So the user knows that he only uh, he canceled the button and the stupid application continued printing it. So the application lied and it doesn't use its capability properly. Considerate products help you avoid awkward mistakes. If a helpful human companion saw you about to do something that you would almost certainly regret afterwards, like shouting about your personal life in a room full of strangers, or sending an empty envelope in the mail to your boss, they might take you quietly aside and gently alert you to your mistake. Digital products should similarly help you realize when you are, for example, about to inadvertently send a text to your entire list of contacts instead of the one friend you were intending to confine in, using rich models feedback, or about to send an email to the director of your department without the quarterly report you mentioned you were enclosing in the text of your message. And the intervention must be in textual feedback that lets you know that you are messaging a group rather than a person, or that you haven't enclosed any attachment even though you mentioned that you were. For this latter situation, your email app might even modestly highlight the drop area for you to drag your attachment to, while at the same time giving you the option of just going ahead and sending the message sans attachments in case the software got your intentions wrong. Products that go extra mile in looking out for users, helping them prevent embarrassing mistakes and not berating them for it, will quickly earn their trust and devotion. All other things equal, considerate product is one of the things, and perhaps even the thing, that distinguishes an only possible app from a truly great one. Designing smart products. A more useful understanding of the term smart, if you're trying to ship a product this decade, is that these products can work hard even when conditions are difficult, and even when users aren't busy. So that's actually the meaning of smart. The application can work on difficult situation or even when the users aren't busy. Regardless of our dreams of thinking computers, there is much greater and more immediate opportunity to get our computers to work harder. The remainder of this chapter discusses some of the most important ways that software can work a bit harder to serve humans better. Smart products put idle cycles to work because every instruction in every application must pass a single file through a CPU. So every instruction actually must pass a single file through a CPU. We tend to optimize our code for this needle's eye. Developers work hard to keep the number of instructions to a minimum, ensuring snappy performance for users. So they work hard to keep that instruction to the CPU because it must pass a single file. But it makes the user work hard. What we often forget, however, is that as soon as the CPU has hurriedly finished all its work, it waits idle, doing nothing until the user issues another command. So these are extra time that we could use to make the CPU smart and work hard and be considerate. We invest in more enormous effort in reducing the computer's reaction time, but we invest little or no effort in putting it to work proactively when it is not busy reacting to the user. So we want the response of this CPU and computer to be fast. However, we put little time in uh, putting it to work when it's idle, which is a lot of wasted energy. Uh, Given that we have a lot of computing power today. Now, our software commands the CPU as though it were in the army. So those command lines like in a command line interface and this GUI, this commands the CPU like in the army, alternately telling it to hurry up and wait. The hurry up is great, but the waiting needs to stop. In our current computing systems, users need to remember too many things such as the names they give to the files and the precise location of those files in the file system. If a user wants to find that spreadsheet with the quarterly projections on it, he must either remember its name or go browsing. So it needs to know the name and then the to navigate, which is which is the huge exercise. And then the location again, the storage retrieval we've discussed in the previous video. Meanwhile, the processor just sits there, wasting billions of cycles. Most users in normal situations can't do anything in less than a few seconds. So people could not it just disrupt the flow of people in that less than a few seconds, but the CPU, that is enough for time for a typical desktop computer to execute at least a billion instructions. So the processor does nothing except wait. The argument against putting those cycles to work has always been we can't make assumptions. Those assumptions might be wrong. So again, we need to differentiate the probable to the possible. Our computers today are so powerful that although the argument is still true, it's frequently irrelevant. Simply put, it doesn't matter if the application's assumptions are wrong. It has enough spare power to make several assumptions and discard the result of the bad ones when the user finally makes his choice. So it could provide those billion assumptions and then the probable based on the user goal to minimize this cognitive um, decision that used to be in command line interface. Now this could be undone because it's only 20% of the time that the user will be mistaken. So with Windows and Apple OS X preemptive threaded, so they preempt that, the threaded multitasking and multi-core, multi-chip computers, the computer can perform extra work in the background without significantly affecting the performance most users see. The application can launch a search for a file, and if the user begins typing, merely abandon the search until the next hiatus. Eventually, the user stops to think and the application has time to scan the whole disk. So the OS X works like this. The application can launch a search for a file, and then if a user begins typing, merely abandons the search until the next hiatus. Eventually, the user stops to think while typing because no one's typed continuously, and the application now has time to scan the whole disk, making it faster so the user won't even notice. This is precisely the kind of behavior that makes OS X Spotlight search capabilities so good. Search results are almost instantaneous because the operating system takes advantage of downtime to index the hard drive. Every time an application puts a modal dialog box, it goes into an idle waiting state. So every time you search that or you open that file, it opens a modal dialog box. It goes into idle waiting state, doing no work while the user struggles with the dialogue. This should never happen. It would not be hard for the dialog box to hunt around and find ways to help. What did the user do last time? The application could, for example, offer the previous choice as suggestion for this time. We need a new, more proactive way of thinking about how software can help people reach their goals and complete their task. Smart products have memory. Developers and designers often assume that user behavior is random and unpredictable, and that users must be continually interrogated to determine the proper course of action. Although human behavior certainly isn't deterministic, like that of a digital computer, it is really random. So being asked silly questions is predictably frustrating for users. If our applications are smart enough to retain any information during and between uses, it is usually information that makes the job easier for the developer, not the user. The application willingly discards information about how it was used, how it was changed, where it was used, what data it processed, who used it, and whether how frequently the application various facilities were used. So these are the billion instructions that we can put the CPU idle time to use. Meanwhile, the application fills initialization files with drivers names, port assignments, and other details that is the developer's burden. So these model dialogues that initiate it instead of remembering the customer's normal and simple function or the few function that he wants to use, uh, put the burden to the customer. It is possible to use the exact same facilities to dramatically increase the software smart from the user's perspective. So it is possible to use the exact same facilities to dramatically increase the software smarts from the user perspective. If your application, website, or device could predict what a user will do next, couldn't it provide a better interaction? If your application could know which selections the user will make in a particular dialog box or form, couldn't that part of the interface be skipped? Wouldn't you consider advanced knowledge of what actions your user take to be an awesome secret weapon of interface design? When we use the term memory in this context, we don't mean RAM, but rather a facility for tracking and responding to user actions over multiple sessions. So it's a facility or tracking like data analytics integrated in the end so that we could track that action and then provide that configuration that is commonly used while responding to user actions over multiple sessions of that window. If your application simply remember what the user did the last several times and how, so the what and how, it can use that as a guide to how it should behave the next time. If we enable our products with an awareness of user behavior, a memory, and the flexibility to present information and functionality based on previous user actions, we can realize a great advantage in user efficiency and satisfaction. We should we would all like to have an intelligent and self-motivated assistant who shows initiative, drive, good judgment, and a keen memory, just like that employee, a proactive employee, or a proactive cleaner at the restaurant or at the kitchen. Simple things can make a big difference. The difference between a product your users tolerate and one they love. So again, if we enable our products with an awareness of user behavior, a memory, and the flexibility to present information and functionality based on previous user actions, we can realize great advantages in user efficiency and satisfaction. Similar products anticipate needs, preventing what a user will do by remembering what he did last is based on the principle of task coherence. Task coherence. So aside from memory, it also anticipates the needs, just like that considerate person that provide relevant information. When a consumer uses your product, there's a good chance that the functions he uses and how he uses them will be similar to what he did in previous uses of the product. This is true not only for tasks such as brushing our teeth and eating breakfast, but it also describes how we use our word processors, email applications, mobile devices, and enterprise software. So this is what I'm talking about. There's a question that the function he uses and how he uses them will be similar to what he did in the previous state. Also, like the Pareto principle, like 80% of the time, we're doing the 20% of the functions. He may even be working on the same documents, or at least the same types of documents, located in similar places. Sure, he won't be doing the exact same thing each time, but his task will likely be variants of a limited number of repeated patterns. This will help you ask questions to users. This will help you ask less questions to users. For example, even though Sally may use Excel in dramatically different ways than she does PowerPoint or Word, she tends to use Excel the same way each time. Sally prefers 12-point Helvetica and uses that font and size with dependable regularity. It isn't really necessary for the application to ask Sally which font to use or to revert to the default. A reliable starting point would be 12-point Helvetica every time. An application can also pay closer attention to clusters of actions. For example, in your word processor, you might often reverse out next, making it white on block. To do this, you select some text and change the font color to white. Without altering the selection, you then set the background color to black. If the application paid enough attention to this action, it would notice that you requested two formatting steps without an intervening selection option. As far as you're concerned, this is effectively a single operation. Wouldn't it be nice if the application, upon seeing this unique pattern repeated several times, automatically create a new format style of this type? Or better yet, created a new reverse out toolbar control for this type of repeated action, such as reverse out, making it white and black. For example, in your word processor, you might often reverse out text, making it white on black. And then to do this, you select some text and then change the font color to white from black, because the text is usually black. Without altering the selection, you then set the background color to black. So most mainstream applications allow their users to set defaults, but this doesn't fit the bill as a smart behavior. Configuration of this kind is an onerous process for all but power users. So you may think that providing a configuration for this type of repeated behavior uh, is smart or considerate for user, but it's not actually, because it's only for power users. If you know that that is the main behavior of the user, and the user usually are not aware of that because they're not aware of idiom concept, they just do that manually. And your application provide a toolbar for that, and then remember that many users will never understand how to customize defaults to their liking. So it will provide this um, uh, smart, and it will anticipate its needs. So smart products remember details. If it's worth it to the user to do it, it's worth it to the application to remember it. Everything that your users do should be remembered. Our hard drives have plenty of storage, and a memory for your application is good investment of storage space. We tend to think that applications are wasteful because a big application might consume 200 millibytes of disk space. That might be typical usage for an application consuming 200 millibytes of disk space, but not for most user data. So if your word processor save 1 kilobyte of execution nodes every time you run it, it still wouldn't amount to much. Suppose you use word processor 10 times every business day. There are approximately 250 workdays per year. So you run the application 2,500 times a year. This is probably not much more than the background image you put on your desktop. So if it's worth it to the user, do it. It's worth it to the application to remember it. Any option users set should be remembered so that the option remain in effect until manually changed. If user ignores aspects of an application or turns them off, they should not be offered again. So if the user already turned that off, you should not provide that option, because now you've learned not to ask question and just provide that option. But since the user manually turn it off, you should not offer it again. The user will seek them out when he is ready for them. One of the most annoying characteristics of applications without memories is that they are so parsimonious with their assistance regarding files and disk. If there's one place where users need help, it's with files and disk. So this is where you need to remember the details more. An application like Word remembers the last place a word look for a file. Unfortunately, if she always puts her file in a folder called letters, and, and then she edits a document template stored in the templates folder just once, also subsequent letters are saved in the templates folder rather than the letters folder. So the application must remember more than just the last place the files were accessed. It must remember the last place files of each type were accessed. So it must remember then more than just the previous file access, but the frequency as well. So if the user edits a document template stored in the templates folder just once and then put it on that template, it will not be appropriate because that's not the usual behavior. It also must remember the place the files of each type were accessed. So kind of like the frequency, depending on the type as well. It must place the same type of file in those same directory. So the position of Windows should also be remembered. If you maximize the document last time, it should be maximized next time. If you position it next to another window, it is positioned the same way the next time without any instruction from the user. Microsoft Office applications do a good job of this. Remembering file locations. All file open facilities should remember where the user gets his files. Most user access files from only a few folders for each given application. So it's the open file in Word. So that's the open file, all file open facilities. The application should remember these source folders and offer them in the open dialog box. So you should remember this commonly used folder, and then when you open, click that open dialog box just like in Word. It is there, so just you can manipulate and open it. The user should never have to step through the tree to a given folder more than once. Deducing information. If the application remembers how many bytes change in the file each time it is open, it can help the user with some checks of reasonableness. Imagine that a file's change byte count is 126, 94, 43, 74, 81, 70, 110, and 92. If the user calls up the file and changes 100 bytes, nothing would be out of ordinary. But if the number of change bytes suddenly shoots up to 5,000 as a result perhaps of inadvertently deleting a page of content, the application might suspect that something is amiss. Although there is a chance that the user has inadvertently done something that will make him sorry, the probability of that is low. So it isn't right to bother him with a confirmation dialog. So it is, however, very reasonable for the application to keep a milestone copy of the file before the 5,000 bytes were changed, just in case. So it's not right to bother him with that confirmation dialog box because the probability of inadvertently doing something is low. And it also useful for the application to have a milestone copy or remember that in the back end, again in the memory of the file before the 5,000 bytes were changed, just in case. Multi-session undo. Most applications discard their stack of undo actions when the user closes the document or application. This is very short-sighted on the application part. Instead, the application could write the undo stack to a file. When the user reopens the file, the application could reload its undo stack. So when the application reopened that, when the user reopened that application, the application could open that stack of file to provide that to the user. So that's actually how we provide this undo. With the actions the user performed the last time the application was run, even that was a week ago. So even if it's a week ago, they can still open it because the stack was saved to the disk. Past data entries. An application with a better memory can reduce the number of error user make. This is simply because users have to enter less information. More of it will be entered automatically from the application's memory. Many browsers offer this function, though few mobile or desktop applications do. In an invoicing application, for example, if the software enter the date, department number, and other standard fields from memory, the invoicing clerk has fewer opportunities to make typing errors in those fields. So few mobile or desktop applications remember this, but browsers have these functions or offer these functions. So usually the ones it being remembered is the uh, enters the date, the department number, and other standard fields from memory, which help the clerk. If the application remembers what the user enters and uses that information for future reasonableness checks, the application can work to keep erroneous data from being entered. So the application can work for the customer to keep that error data from being entered. We just need to remember what's the previous search with the future reasonableness. Contemporary web browsers such as Internet Explorer and Firefox provide this facility. Name that data entry fields. Remember what has been entered into them before and allow users to pick those value from a combo box. So those search the options that we see in this search engine is actually combo box, and the entry is actually name data entry fields control. So for security-minded individuals, this feature can be turned off, but for the rest of us, it saves time and prevent errors. Foreign applications activities on application files. Applications might also leave a small thread running between invocations. This little application can keep an eye on the files it has worked on. It can track where the files go and who reads and writes them. This information might be helpful to a user when he next runs the application. When he tries to open a particular file, the application can help him find it even if it has been moved. The application can keep the user informed about what other functions were performed on his file, such as whether it was printed or emailed. Sure, this information might be unneeded, but the computer can easily spare the time and only bits have to be thrown away after all. So you can also track it using foreign application activities on application files. Using this small thread running between invocations. So every time the application invokes a function, so this little application will keep an eye on files it has worked on. It can track where the files go and who reads and writes to that file. So it's all about this file on the disk. This information might be helpful to a user when he next runs the application. Making smart products work. A remarkable thing happens when you implement task coherence. Designers find that their thinking takes on a whole new quality. The normally understood recourse of popping up a dialog box gets replaced with a more studied process in which the designer asks much more subtle questions. How much should the application remember? Which aspects should it remember? Should the application remember more than just the last setting? What constitutes a change in pattern? Designers start to imagine situations like this. The user accepts the same date format 50 times in a row and then manually enters a different format once. The next time user enters a date, which format should the application use? Of course, the format used 50 times. Or the more, is it the format used 50 times or the more recent one time format? How many times must the new format be specified before it becomes default? Even though the ambiguity exists, the application still shouldn't ask the user. How many times must the new format be specified before it becomes default? Even though the ambiguity exists, the application still shouldn't ask the user. It must use its initiative to make a reasonable decision. Decision set reduction. People tend to reduce an infinite set of choices to a small, finite set of choices. Even when you don't do the exact same thing each time, you tend to choose your actions from a small, repetitive set of options. People perform this decision set reduction unconsciously, but software can take notice and act on it. For example, just because you went shopping at Safeway yesterday doesn't necessarily mean you shop at Safeway exclusively. However, the next time you need grocery, you probably will shop at Safeway again. Similarly, even though your favorite Chinese restaurant has 250 items on the menu, chances are you usually choose from your personal subset of 5 or 6 favorites. When people drive to and from work, they usually choose from a small number of favorite routes, depending on traffic conditions. Computers, of course, can remember 4 or 5 things without breaking a sweat. Although simply remembering the last action is better than not remembering anything, it can lead to a peculiar pathology if the decision set consists of precisely two elements. For example, if you alternately read files from one folder and store them in another each time the application offers you the last folder, it is guaranteed to be wrong. The solution is to remember more than just one previous choice. Decision set reduction guide us to the idea that pieces of information the application must remember about the user's choices tend to come in groups. The application should look for more subtle clues to differentiate which one of the small set is correct. For example, if you use a check writing application to pay your bills, the application may very quickly learn that only 2 to 3 accounts are used regularly. But how can it determine from a given check which of the 3 accounts is the most likely to be appropriate? If the application remembered the pays and amounts on an account by account basis, the decision would be easy. So the key here is remembering those attributes, other attributes, and then paying attention to that. I mean, recording that in the database. But usually on this decision set, though you sometimes use other restaurant or other menu, you usually go back to those small few groups or decision. Every time you pay the rent, it is the exact same amount. It's the same with the car payment. The amount paid to the electric company may vary from check to check, but it probably stays within 10 or 20% of the last check written. All this information can be used to help the application recognize what's going on and use that information to help the user. Preference thresholds. The decision people make tend to fall into two primary categories: important and unimportant. Any given activity may involve hundreds of decisions, but only a few of them are important. All the rest are insignificant. So like the 80-20. After you decide to buy that car, you don't really care who finances it as long as the terms are competitive. After you decide to buy groceries, the particular checkout aisle you select may be unimportant. After you decide to ride the Matterhorn at Disneyland, you don't really care which bobsled they sit you in. So you only care about those few things. Preference threshold guide us in our user interface design by demonstrating that asking users for successively detailed decision about a procedure is unnecessary. This perseverance threshold provide us a concept that 80% of the time we choose or we only care of those few functions. So those simple tasks such as that configuration that pops up that ask the beginner user or the intermediate user for such a simple task is unnecessary. After a user chooses to print, we don't have to ask him how many copies he wants or whether the image is landscape or portrait. We can make an assumption about these things the first time out and then remember them for all subsequent invocations. With preference thresholds knowledge, application can offer choices where it has an expectation that users wants control, because we can easily track which facilities of the application each user likes to adjust and which are set once and ignored. So we can easily track those functions or facilities that the application each user likes to adjust and which are set once and ignored, such as in configuration. Mostly right most of the time. If we can reliably predict what the user will do 80% of the time, this means that 20% of the time we will be wrong. It might seem that the proper step to take here is to offer users a choice, but this means that they will be bothered by an unnecessary dialog box 80% of the time. Rather than offering a choice, the application should go ahead and do what it thinks is most appropriate and allows user to override or undo it. If the undo facility is sufficiently easy to use and understand, users won't be bothered by it. After all, they will have to use undo only 2 times out of 10 instead of having to deal with redundant dialog box 8 times out of 10. So just provide the undo because it's mostly right most of the time. Designing social products. Most of the content created in modern software isn't made for the sole of use of its author. Task lists, reminders, and personal journals are perhaps the exceptions. Most content is passed on to other humans. Presentations to be heard, documents to be read, images to be seen, status updates to be liked, as well as content to be reviewed, application, and used in the next step of some business process. Even lines of application code that are meant for machines are still written in structures and using language that is meant to be readable by other developers. Software has grown more complex and more respectful of the goals of its users. Those sharing and collaboration features are built right in. Software is becoming less like a private office into which one disappears to produce work and later emerges work in hand, but more like an open plan office where collaborators and even consumers are just a shout away. When we communicate with others, users via software mediated mechanisms, the principle is the same but must additionally take into account social norms and expectation of the other users. So it's more like an open plan office now where collaborators and even consumers are just a shout away because we either do a presentation to be heard, documents to be read, images to be seen, status updates to be liked, as well as content to be reviewed, application, and used in the next step of some business process. So kind of like we are now a content creator, all of us is content creator. When we communicate with others via software mediated mechanism, the principle is the same but must additionally take into account social norms and the expectation of the other users. Social products know the difference between social and market norms. Every group has its own set of rules to which its members adhere, but the two largest categories are social norms and market norms. Social norms are the unspoken rules of reciprocity afforded to friends and family. They include things like lending a hand when in need and expressing gratitude. Market norms are a different set of unspoken rules afforded to people with whom one is doing business. They include things like assurances of fair price for quality goods and honesty in dealings. Mistakenly using market norms in a social setting can be perceived as extremely rude. Imagine leaving money on the table after enjoying a good meal at a friend's house and then leaving. Mistakenly using norms in a market settings can get you arrested. Imagine shaking the hand of the waiter at a restaurant and saying, "Thank you, that was delicious," and leaving without paying. If your software is to avoid being either rude or illegal, it must know the norms in which its user operate. Some software toys with these rules a little bit. You are connected to friends through LinkedIn. There are companies with pages on Facebook. Software used internally at organization operates on semi-social rules since its members are helping each other do the organization business. So sometimes the internal business operates in a semi-social rules. Dating software are actually markets where transaction is agreeing to meet. So they must respect the transaction or market needs. Software adhering to market norms should assure both parties in a transaction that deal will be fair, often asking as the matchmaker and trustworthy escrow agent. Software adhering to social norms should help its users adhere to the subculture rules and hierarchy and reciprocal rewarding ways. So it should adhere to the social norms in that culture, and it should need to adhere with the subculture rules and hierarchy and reciprocal rewarding ways. Social software lets user present their best side. Representing users in a social interface poses challenge to the designer. That is how to make those presentations unique, recognizable, descriptive, and useful. So the challenge with social interfaces is that how to make the profile unique, recognizable, descriptive, and useful. So user identity, it's tempting to use name and assign semi-random avatars colored animal icons. But name is not unique and avatar add cognitive load in remembering the person behind the icon. To keep this load to a minimum, let the user on the other end provide a visual that works best for them, either by selecting an unclaimed icon color combination themselves or by uploading their own image. Uploading image does introduce the risk that inappropriate content may be chosen. But within opt-in networks and accountable non-anonymous social software, social pressures should keep this in check. In any case, adding a tooltip for a full name offers user a quick reminder about who is who should they need it. Dynamic versus static users profiles. So you can also add a tooltip for a full name or to offer user a quick reminder who is who. Dynamic versus static user profiles. User profiles are traditional way that a user can create an online presence for themselves, but not all users have the time or desire to fill out a bunch of static fields describing themselves. However, a user's social contribution to the network can be dynamically collected and presented in summary. Music listened to, people followed or friended, updates added or liked, books or movies mentioned, links posted or shared, etc. So a user profile is actually a card base, just like in Facebook. It allows to see how many friends, how many follows them, etc. Facebook timeline is an example of one way of presenting this kind of information, kind of like a compact way to see the profile. And it could be that's how we actually dynamically collected that profile. So a static user profile is actually just a static it's just a default settings of profile, static image. So Facebook Thailand is an example of one way of presenting this kind of information. In social networks, actions speak louder than self-descriptions. And summarized top-rated or best-like contribution can form a great supplement or even alternative to static bios. So the summarized top-rated or best-like contribution from a timeline can form a great supplement or an alternative to static self-description of profile. Social software permits easy collaboration. Collaboration is one of the most common reasons to make software social. A user may desire a second opinion, another pair of hands, or a sign-off by a colleague. Collaboration-centric social software can bake this type of functionality deeply into the interface. This is actually the most common use for this. A presentation to make images to react to, status to be updated. So these are the reason for these social apps. Before Microsoft Word lets people, the usual communication is not through Facebook. Like Microsoft tried to let people, they let people add review comments to documents, and others can add comments referencing earlier ones. It works after a fashion, but comments can unfortunately get jumbled and disassociated from their source. Google Docs does Word 1 better by allowing collaborators to reply directly to comments. Treating them almost as threaded discussion lets any collaborator resolve an issue with a click of a button and supplies a place where old resolved issues can be reopened. So Google made it better by allowing them to reply directly to comment, treating them almost as threaded discussion. So it lets any collaborator resolve an issue with a click of a button. So it made them easy and supplies a place where old resolved issues can be reopened. So it makes like a threaded discussion. It is not jumbled and disassociated from there. So social products know when to shut door. In productivity software that is only peripherally social, such as Google Docs, the socialness of the software should not overwhelm or distract from the primary task. Of course, social software must manifest other users, but it should do so carefully, treating the attention of the user with the utmost respect. Social products help networks grow organically. Networks of people grow and change over time as members join, connect, interact, gain standing, and leave. Social software must have ways for new members to discover the network, join, build a presence, learn the rules, begin to participate, and receive gentle reinforcement when the member transgresses against the subculture's norms. So people changes and grow over time. It's normal for Facebook to unfriend, to leave a message group, etc. Intermediate members should have tools that let them build mastery, nurture newer members, and seek help from senior members. Senior members should have tools to manage the network. All members need ways to suspend participation for a time, or to elegantly bow out. And as morbid as the thought may be, networks must elegantly handle when their members die. A particularly difficult social problem is how to handle when one user wishes to connect to another user who does not agree to the connection. Per social norms, the reluctant user can come across as aloof or standoffish. When the new mailroom intern tries to connect via LinkedIn to the CEO of a large organization, the CEO doesn't want to connect but also doesn't want to send a signal that employee isn't valued. To let the eager user save face, the reluctant user need to pass responsibility to a set of explicit rules for the community to another user who is expressly charged as a gatekeeper or to some system constraint. Social products respect the complexity of social circles. Research from primatology has revealed that the size of the neocortex in a primate's brain has a direct correlation to the average size of its tribe. Tribes with a number of members smaller than this value risk having less security. Tribes with a number of members larger than this value become unstable. This name from anthropologist Wu first proposed it called Dunbar's number. For example, your college friends may delight in photos of your night of irresponsible carousing, but only some of your family would, and your employer or clients would almost certainly not. Unfortunately, the mechanism for managing these circles and specifying which content goes to which circle is hard to find and cumbersome to use, occasionally resulting in some very embarrassed Facebook users. The ability to change permission on the fly, retract actions is critical in such contexts. Facebook rival social network Google Plus provides its user with a much clearer mechanism for understanding and managing social circles, with animations and modern layout that makes it fun rather than a chore. Core. The larger and more complex your software is, the more design attention you will need to pay to the complexity of the social network. Explicitly social software can involve massively disparate circles of people. Facebook, with its estimated 1 billion users, can find its user connected to workers, nuclear family, extended family, friends, frenemies, neighbors, ex-neighbors, schoolmates, ex-schoolmates, acquaintance, hobbyist circles, employers, potential employers, employees, clients, potential clients, sweethearts, paramounts, and suspicious rivals, to name a few. The rules and norms for each of these subgroups can be of critical importance to the user, as can keeping groups separate. The rules and norms for each subgroup for this is critically important to the user, such as and keeping groups separate, such as the timeline, where your most recent like person determine the what will show on your timeline. So that's actually the algorithm working for you. Social products respect other users' privacy. Advertising-driven social media like Facebook and Google Plus have a strong financial incentives to disrespect their users' privacy. The more that is known and shared about a particular user, the more targeted advertising becomes, and the higher the fees that can be charged to advertisers. Facebook in particular has run into problems time and again where it changes policy to expose more user data, does not explain the change to user satisfaction, and makes controls for the change difficult to find, understand, and use. Thus, a user commenting on a risk picture is suddenly shocked to find her aunt Bessie scolding her for it. Facebook repeated inconsiderate misstep risk it slowly turning its user against its brand. Considerate social products makes additional sharing a carefully explained opt-in affair, and in the case of business norm, it can be intellectually property rights violation, so take great care. Social products deal appropriately with anti-social. Grifters are users who abuse social systems by interfering with transactions, adding noise to conversations, and even sabotaging sabotaging work. Amazon has had to deal with an entire subculture of grifters who delight in proving sarcastic reviews to goods on sale. In large network systems with easy and anonymous account creation, grifters have little accountability for their action and can be a major problem. The trick in these tools is to help caretakers distinguish the genuinely antisocial user from those who are earnest but unpopular. Uh, Platform and posture. A product's posture is its behavioral stance, how it presents itself to user. Posture is a way of talking about how much attention the user devotes to interacting with the product and how the product's behavior respond to the kind of attention the user devotes to it. So it's actually a behavioral stance, how it presents itself to users. It's a way of talking about how much attention the user devotes to it, whether it's transient or sovereign, which we are discussing since the previous video, while interacting with the product and how the product's behavior respond to the kind of attention the user devotes to it. This decision must be based on an understanding of likely usage contexts and environments. So this platform in posture is in response to the usage context and environments. Usage context for posture and platform for environments. Product platforms. Platform are used to describe a number of important product features such as the physical form, display size and resolution, input methods, network connectivity, operating system, and database capabilities. So the platform is kind of like the environment that used to describe a number of important product features, such as the physical form. So it's not just the environment, the physical form as well, the display size, resolution, input methods, how would you input it, whether it's touch screen or mouse, network connectivity available on that area, such as is it kiosk, is it a desktop-like operating system, because that will determine how capable the device. If it's a desktop, it's more capable for complex capabilities. Is it the database capabilities? Is it a web application that allows you to sync into the cloud automatically? Or is it on a tablet or one-time posture application such as syncing application, which is the like a Kindle book. Each of these factors has a significant impact on how the product can be designed, built, and used. Choosing the right platform is a balancing act. You must find the sweet spot that best supports the needs and context of your personas, but also fits within the business constraints, objectives, and technological capabilities of your company or client. So it's kind of like the design job as well. You need to get this right because sometimes you don't need to be strict on the details. You need to just choose the right platform that best support the context of your persona, that also fit with business constraints, objectives, and technical capabilities. In many organizations, platform decisions, particularly those regarding hardware, unfortunately are still made well in advance of the interaction designer's involvement. It is important to inform management that platform choices will be much more effective if they are made after interaction designers complete their work. Design principle. Decision about a technical platform are best made in concert with interaction design efforts. Product postures. Platform and posture are closely related. Different hardware platforms are conducive to different behavioral stances. A social networking application running on a smartphone clearly must accommodate different kind of user attention and level of interaction than say a page layout application running on a large display desktop computer. So, the behavioral stance of social networking application running on a smartphone should provide more features than say a page layout application running on a large display desktop computer. As software applications may be bold or timid, colorful or drab, but they should be that way for a specific set of goal-directed reasons. The presentation of an application affects how users relate to it, and this relationship influences the product usability and desirability. So how it is presented to the user, whether it's full screen for a sovereign application, determines how the user perceive it and its product usability and desirability. Apps whose appearance and behavior conflict with their purpose will seem jarring or inappropriate. That's why you see this awkwardness in some contexts, or it's kind of like the idiom where it's good, you look good, but you're always out of context. Kind of like the same with this application that is put in the wrong context. So, from the perspective of posture, look and feel is not solely a brand or an aesthetic choice. It's a behavioral choice. Your application posture uh, is part of its behavioral foundation, and whatever aesthetic choices you make should be in harmony with this choice posture. So the look and feel is not solely a brand or an aesthetic choice or the brand attributes we've choose in the previous video. Rather, it's also a behavioral choice. So your application posture should be congruent or in harmony with this posture, whether it's a sovereign or transient application. Just as you present yourself to others in somewhat different ways depending on the social context, some products may exhibit characteristics of a number of different postures in a different usage context. For instance, when reading email on a smartphone during a train ride, the user may devote concentrated attention to interaction with the device and expect a commensurate experience. However, the same user will have a significantly less attention to devote if she is using it to look up an address while running to a meeting. So just as you would present to others in somewhat different ways depending on social context, products are different for different characteristic and a number of different posture depending on their context for different people. So for some, that's a sovereign application. For some, it's transient. For instance, when reading email on a smartphone during a train ride, the user may devote concentrated attention to interaction with the device and expect a commensurate experience. However, the same user will have significantly less attention to devote if she is using it to look up an address while running to a meeting. So that's a different context, so different attention applied to that posture. So you need to design the app depending on the most common posture for that application. Though some people like use desktop while on the train, it's not a usual posture or most usual use of the application. Most of them it's just in one location. It's stuck in one location. So just as posture for desktop. Generally speaking, interaction design has its root in desktop software. While historically designers have grappled with issues related to complex behaviors on a variety of technical platforms, desktop and laptop computers have brought these complex behaviors into the mainstream. So historically, designers have issues with this complex behavior in a variety of technical platforms. Desktop and laptop have brought this into the mainstream. It allows the designer to see how complex it could be to design this application that will fit most users. In more recent history, web applications, mobile devices, and digital appliances of many kinds have expanded both the repertoire of behaviors and their mainstream reach. So it represents this different behaviors and their mainstream reach. Desktop applications express themselves in three categories of posture: sovereign, transient, and daemonic. Because each describe a different set of behavioral attributes, each also describe a different types of user interaction. So, so because each describe a different set of behavioral attributes or properties of that application, it also describe a different type of interaction. So here, sovereign application. Sovereign application offer a large set of related functions and features, and users tend to keep them up and running continuously, occupying the full screen. A good example of this type of application are word processors, spreadsheet, and email applications. Many job-specific applications are also sovereign applications because they are often deployed on the screen for long periods of time. And interaction with them can be deep and complex. Users working with sovereign application often find themselves in a state of flow, which we discussed in the previous video. Sovereign applications are usually use maximize. We'll talk more about Windows states, but we've talked that in the previous video, the Windows states. For example, it is hard to imagine using Microsoft Outlook in a 3x4-inch window. That size is inconvenient for Outlook's main job, allowing you to create and view email and appointments. A sovereign product dominates the user workflow as his primary tool. So here, Microsoft Outlook is a classic example of a sovereign posture application. It stays on screen, interacting with the user for long, uninterrupted periods. And with its multiple adjacent panes for navigation and supporting information, it begs to take up the full screen. Target intermediate users. Each user spends time as a novice, but only a short period of time relative to the amount of time he will eventually spend using the product. So it's only a small time compared to intermediate. So certainly a new user has to get over the initial learning curve. So one of the ways or the key principles in designing for this type or sovereign user flow application is to target intermediates. Certainly, a new user has to get over the initial learning curve, but seen from the perspective of the entire relationship between the user and the product, the time spent getting acquainted with the application is small. In any case, the sort of user you're optimizing for is determined by your choice of primary persona and understanding of his or her attitudes, aptitudes, and use context. WordStar Corporation thrived until its competition offered the same power for intermediate users while simultaneously making the application much less painful for infrequent users. So, WordStar Corporation before actually thrive because it focused on intermediate, but it doesn't do as well in the beginners which is also important. That's why their business failed. So be generous with screen real estate. Because the user's interaction with sovereign application dominates his session at the computer, the application shouldn't be afraid to take as much as screen real estate as possible. No other application will be competing with yours beyond the occasional transient notification and communication apps. So those transient notification and communication apps are the one competing application on this sovereign. So you should be generous with screen real estate. If you need 4 toolbars to cover the bases, use 4 toolbars. In an application of a different posture, 4 toolbars may be overly complex, but the sovereign posture has a defensible claims on the pixels. In the absence of explicit instruction from the user, your sovereign application should default to maximize or full screen presentation. So in the absence of a clear instruction from the user, your sovereign application should default to maximize or full screen. So this is the default settings for sovereign application. The application needs to be fully resizable and must work well in other screen configuration. But the interface should be optimized for full screen use instead of the less common cases. Design principle: optimize sovereign application for full screen use. Use a minimal visual style. Because users will stare at a sovereign application for long periods, you should take care to mute the colors and texture of the visual presentation. So you need to take care of muting the colors and texture compared to transient application, because they will be staring on it for a long time. So it will be hard for the eye. That's why some of the laptop that has this bad color is so distracting and makes you unable to stare at it for a long time, like my Lenovo laptop. Keep the color palette narrow and conservative. So you keep the color palette narrow and conservative. So the color difference in color should be narrow and conservative, depending on the attributes that you want to pursue with the theme of your company. Big colorful controls may look really cool to newcomers, but they seem garish after a couple of weeks of daily use. So big colorful controls may be better for new user, but for intermediate it's not. Tiny dots or accents of control will have more effect in the long run than big splashes, and they enable you to pack controls and information more tightly than you would could otherwise could. So a tiny dots or accents of color, like tiny colors or tiny icon, would be better because you're optimizing for intermediate. The user will stare at the same palette, menus, and toolbars for many hours, gaining an innate sense where things are from sheer familiarity. This gives you, the designer, freedom to do more with fewer pixels. Toolbars and their controls can be smaller than normal. So it could be smaller than normal. Auxiliary controls such as screen splitters, rulers, and scroll bars can be smaller and more closely spaced. So it could be smaller and more closely spaced, just like in Word, the word count and then the indentation, etc., are closely spaced. So design principles: sovereign interfaces should feature a conservative visual style. Provide rich visual feedback. A status bar at the bottom of the screen, the ends of the space normally occupied by scroll bars. The title bar and other dusty corners of the product visible components can be filled with visual indications of the application status, the data status, the system status, and hints for more productive user interaction. The system, data, and application status could be found in the title bar and other dusty corners, and in scroll bar as well, near the scroll bar. It could provide hint for more productive user actions. So this is actually how you make it instinctive and optimized for intermediate users and make it easy to learn as well. The first-time user won't even notice such artifacts, let alone understand them, because the subtle way they are shown on the screen. After a period of steady use, however, he will begin to see them, wonder about their meaning, and experimentally explore them. If you provide an easy means for him to find out what the artifacts are, he will become not only a better user, but also a more satisfied user. His power over the application will grow with his understanding. Adding such richness to the interface is like adding a variety of ingredients to soup stock. It enhances the entire meal. Support rich input. Sovereign applications similarly benefit from rich input. Every frequently used aspect of the application should be controllable in several ways. Direct manipulation, keyboard mnemonics, and keyboard accelerators are all appropriate. So keyboard accelerators, we discussed that in the previous video. Direct manipulation and then keyboard that support this rich input. So usually for sovereign application, you usually have this laptop and desktop, because those are the things that provides this rich input, that provides these complex commands or paragraphs. So design principle: sovereign application should exploit rich input. Go ahead and use the corners and edges of the application's windows for controls. In Word for Mac, Microsoft has put the most frequently used functions at the top of the window, as shown in figure 9.2. Microsoft also put visually dislocating functions on small controls near the bottom of the screen. So you need to use the corners and edges of the application windows for its controls. In Word for Mac, Microsoft has put the most frequently used function at the top of the window. So they use here, they put the most frequently used function at the top, as shown in figure 9.2. Microsoft also put visually dislocating functions on small controls near the bottom of the screen. So here it will dislocate, like the lever seat that we've discussed in the previous video. There's two types of levers: visually dislocating, things that will change the layout enormously, and those that is irreversible. It is put as a small controls because it's mainly target for intermediate and expert users. So these controls change the appearance of the entire visual display: draft view, outline view, publishing layout view, print out layout view, notebook layout view, and focus view. So those change the view of this window in drastic ways. Placing them near the bottom of the screen makes them almost inevitable to new users. Their segregated positioning subtly and silently indicates that they should be used with caution for experienced users. However, will experimentally selects them when they feel fully prepared for the consequences. So at the bottom, it's almost invisible to the new users. Their segregated positioning subtly and silently indicates that they should be used with caution. So the position at the bottom. So Microsoft Word has place controls at both the top and bottom of the application. The controls at the bottom are used to change views and are appropriately segregated because they can cause significant visual dislocations. Designed for documents, child windows containing documents should always be maximized inside the application unless the user explicitly instruct otherwise or the user needs to simultaneously work in several documents to accomplish a specific task. So a child window containing documents should be maximized unless the user explicitly instruct otherwise because it's sovereign application or the user needs to simultaneously work in several documents. So it should have one main content of the document or main on the main pane area. So design principle: maximize document views within sovereign applications. Many sovereign applications are also document centric. In other words, their primary function involves creating and viewing documents containing rich data. So a lot of these are actually document centric. Their primary functions or primary features involves are creating and viewing this document that contains rich data. This makes it easy to believe that the two are always correlated, but this is not the case. If an application manipulates a document but performs only a single simple function, such as scanning an image, it isn't a sovereign application and shouldn't exhibit sovereign behavior. So for a document application that only has single and simple function, such as scanning image, it is not sovereign application. It should exhibit a more transit posture of application. So, a lot of this sovereign application is actually a document centric. So, their main feature or functions is just creating and viewing or creating and reading this document that has rich data. When we say rich data, it has this multimedia or like multiple data. It could have video, links, text, video, images, etc. Transient posture. A product with a transient posture comes and goes, presenting a single function with a constrained set of accompanying controls. So it comes and goes because it's not in the main pane area. It only presents a single function with a constrained set of accompanying controls. So this transient application is usually just a single function that we manipulate in the properties, such as a print, all related functions with print, that with a constraint set of accompanying controls. Constraint because they are grouped in that dialog box. So the application is invoked when needed, appears, perform its job, and then quickly leaves, letting the user continue her normal activities. It only invoke when needed, appear, perform its job, and then quickly leaves, letting the user continues her normal job activities, usually with a sovereign application. Consequently, the product's user interface should be obvious and helpful, presenting its control clearly and boldly with no possibility of confusion or mistakes. So the interface here is compared to sovereign should not be small. If possible, it should be clearly and boldly with no possibility of confusion or mistakes. This is not the place for artistic but ambiguous image and icons. For example, calling up File Explorer in Windows, it's actually a type of transient application to locate and open a file while editing another with Word is a typical transient scenario. So it's setting your speaker volume. So there's actually is an transient app as well, because the transient application borrows space at the expense of the sovereign. It must respect the sovereign by not taking up more space than is absolutely necessary. In cases when the entire computer system is fulfilling a transient role in the real world, it is not necessarily appropriate to minimize the use of pixel and visual attention, because you're actually performing a physical activity or could be a life-threatening. So it is critical for information to be obvious and clearly understood from across the room. So this clearly requires a bolder use of color and a more generous allotment of real estate. So here figure 9.3 is an example of that. OS X dashboard widgets and iTunes mini player are good example of transient applications. They are referred to interacted with briefly before the user's attention turns into an activity in a sovereign application. The use of rich dimensional rendering gives them an appropriate amount of visual gravity. Making it bright and clear, bolder graphics helps users to orient themselves more quickly when the application pops up. So if you make it bright and clear, or such as using bolder graphics, it helps to orient. Again, one of the visual principle, orientation. If you make it larger, the user actually see what's important immediately. The user may see the application only once a month and will likely forget the meanings and implication of the choices presented. Instead of having a button labeled Set Up, it's better to make the button large enough so it can be labeled Set Up User Preferences. The verb or object construction results in a more comprehensible interface, and the result of clicking the button are more predictable. So the verb and an object construction of this setup user interface provides a sentence, because sentences are more easily understandable, because words we need to put a lot of cognitive load to understand what that word means, compared to sentence which is more detailed and precise. Results in a more easily comprehensible interface, and the result of clicking the button are more predictable. Keep it simple, so all the information and facilities he needs should be right there on the surface of the application single window. There shouldn't be a secondary windows. Transient applications are not the place for tiny scroll bars and fuzzy mouse interaction, because you want to keep demands on users' fine motor skills to a minimum. So make it simple. All the information in that one dialog box, in that single window. There shouldn't be a secondary window or another dialog box would provide another cognitive load. Transit applications are not the place for tiny scroll bars and fuzzy mouse interactions. It should not be in tiny scroll bars and fuzzy mouse interactions because you want to keep demands on users' fine motor skills to a minimum. So it's not actually a place for these tiny scroll bars that we have in Windows apps such as this OneNote and fuzzy mouse interaction because or like any complex mouse interaction because you want to keep demands on users' fine motor skills to a minimum. You don't want drag and drop, double click, etc. Design principle: transit applications should be limited to a single window in view. Simple push buttons for simple functions are good. Direct manipulation can also be effective, but anything that can be directly manipulated must be discoverable and big enough to interact with easily. So a simple push button instead of the 3D static hinting is good. And then it should be big enough. So the big are constantly emphasized here. You can provide keyboard shortcuts, but they must be simple and all important functions should be also be visible on the interface. So because you're not doing complex interaction, you should minimize it in one hierarchy or one degree of complexity, such as only one tap or there's no any motor skills needed. You can provide shortcut but it's only simple, etc. And all important are visible. So here is a good example of a transient application. Art Director's Toolkit by Codeline Communication is a transparent application. It provides a number of discrete functions such as calculating dimensions of a layout grid. These functions are designed to support the use of sovereign layout applications such as Adobe InDesign. The many functions are organized into tabs and are directly accessible at all times. So a lot here are accessible through tabs, grid spreads, and the width, etc. So this means that the transit application, as it positioned on top of the sovereign, may obscure the very information that is chartered to work on. This implies that the transient application must be movable, which means it must have a title bar or other obvious affordance for dragging. So it should be it must be movable window as well. It must have a title bar, and it must have other obvious affordance for dragging, such as here the opposite arrow. Remember user choices. If a transient application remembers where it was the last time it was used, the same size and placement probably will be appropriate next time too. These settings will almost always be more suitable than any default setting might happen to be. So anything that has been previously used for this transient application is better than any default setting might be. So it's counterintuitive with the memory that we've discussed earlier, in which the most common directory in files because their dialog box, it's really used kind of like once a month, so you want to use the previous state. Whatever shape and position the user left the application in should be the shape and position the application reappear in when it is next summoned. Of course, this holds true for its logical settings too. And remember, dialog boxes are the most common transient applications. So the most common transient application are actually this dialog model box. Design principle: a transient application should launch to its previous position and configuration. Daemonic posture: this application should quietly and invisibly in the background, performing vital tasks without the need for human intervention. So these are the actually the background apps that we've been talking about in the previous video. A printer, driver, and network connection are excellent examples, whereas a transient application controls the execution of a function. A daemonic application usually manages processes. Your heartbeat isn't a function that must be consciously controlled. Rather, it is a process that proceeds automatically in the background, competently doing their job, while the computer is turned on. Or where you arrive, right? Alive, right? Unlike your heart, however, daemonic applications must occasionally be installed and removed. And also, occasionally, they must be adjusted to deal with changing circumstances. It is at this time that a daemon talks to the user, or vice versa. So sometimes it should be installed and removed, and occasionally need to be adjusted. It is where the user talks to this application. Without exception, the interaction between the user and a daemonic application is transient in nature, and all the imperatives of transient application design hold true here also. So it is transient in nature as well, but it's more transient than the transient application, and all the principles in transient application design is hold true here as well. Daemonic icons should be employed persistently only if they provide continuous and useful status information. So daemonic icons should be employed persistently only uh, if they provide continuous and useful status information. So it is only employed like this as speakers that change this icon depending on the and the drop box as well, depending on its status if it's useful for the context. Microsoft solved this problem by hiding daemonic icons that are not actively being used to report status or access functionality in a pop-up menu, as shown in figure 9.5. So figure 9.5, that's status area of the taskbar in Windows 8. The speaker icon provides modeless visual status information because the icon changes if the speaker's volume is low or muted. Hovering over the icon provides more information, and clicking or right-clicking it provides access to the volume and other audio controls. So to the right of the speaker icon, the Dropbox icon modelessly indicates that Dropbox is automatically syncing its desktop folder. Both Mac OS and Windows also employ control panels as an effective approach to configure daemonic application. The user activate transient application give users a consistent place to configure daemons. So there's also a control panel in Windows that allows us to configure this. So that's actually what we are configuring in Windows. This user activated transient application give user a consistent place to go to configure daemons. It is also important to provide direct inline access to daemonic application anytime an issue with them prevents someone from accomplishing what he aims to. Of course, the standard disclaimer applies. Don't interrupt users unnecessarily. For example, if a taskbar icon indicates a problem with the printer, clicking that icon should provide a mechanism to troubleshoot and rectify the problem. So that's what you often see in Windows. Just a moment, guys. I'll just drink sip water. So let's continue. Postures for the web. As with many of the categorizations we offer in this book, the lines between them can be indistinct. Think of them as representing a spectrum on which any website or web application can be located. So for all the categorization we've done uh, here, such as those transient, those persona, primary, uh, things could overlap uh, at the same time with the sovereign, transient, and for desktop, mobile controls, and dialogues. Things could overlap that makes it complex. So here, we're just gonna try to demystify it by categorizing it. Informational website posture. Web browsers were originally conceived as a way to view, shared, and linked documents without the need for cumbersome data transfer utilities like File Transfer Protocol, Gopher, and Archie. The early web was made up of sequential or hierarchical sets of the documents, web pages, collectively called websites. Web browsers were originally conceived of as a way to view, shared, and link documents without the need for cumbersome data transfer utilities like, oh, it was just repeated. So basically, it was created to share link of documents with it without the need of file transfer or FTP or downloading the documents. So it's just we made of a hierarchical set of documents or web pages, collectively called websites. So balancing sovereign and transient applications. Sites that are purely informational that require no complex transaction beyond navigating from page to page and limited searching must balance two forces. The need to display a reasonable density of useful information and the need to allow first time and infrequent users to learn and navigate the site easily. So, for sovereign, that sites that are purely informational, that no complex interaction beyond navigating from page to page and limited. There's two forces at play: the need to display a reasonable density of useful information, and the need to allow first-time and infrequent users to learn and navigate the site easily, kind of like in the sovereign and transient as well. So which stance is more dominant depends largely on who the target persona are and what their behavior patterns are when they use the site. Are they infrequent or one-time users, or are they repeated users who will return weekly or daily to view content? Informational sites where real-time information naturally will attract repeat users more than a site updated once a month. Infrequently updated sites may be used more occasional reference, assuming that the information is not too typical rather than for heavy repeat use, and thus should be given more of a transient stance than a sober ones. So the infrequent update sites should be treated as a transient. So what's more, the site can configure itself into a more sovereign posture by paying attention to how often a particular user visits. So by having a data analytics on how the user respond, you can actually make it more useful or more sovereign. Sovereign attributes, by assuming the full screen use, designer can take advantage of all the space available to clearly present the information as well as navigational tools and wayfinding cues to keep users oriented. So by assuming full screen use, designer can take advantage of all the spaces available to clearly present the information, as well as navigational tools and wayfinding cues to keep users oriented. So it's the same with desktop apps. You want it full screen as well as navigational tools and wayfinding cues to keep users oriented. Designers need to decide early on what resolution they will optimize the screen design for. You can use a responsive approach to flexible display content in a variety of browser window size, with interfaces that can even scale smoothly between the many variants of mobile and desktop screen size. However, your design should be optimized for the most common display sizes used by your primary and sometimes secondary persona. Quantitative research is helpful in determining this. Among people similar to your persona, how many are still using 800 times 600 pixel display? So you need to take advantage of the screen, of the full screen for sovereign attributes of this uh, website. So because the users may bookmark sites that they use infrequently for reference, you should make it possible for them to bookmark any page of information so that they can reliably return to it later. It's beneficial if these sites can retain information about past user actions via cookies or server-side methods and present information that is organized based on what interested the user previously. So because users might bookmark sites that they are used infrequently for reference, you should make it possible for them to bookmark any page so they can reliably return it later. So most browser has this feature already. It's beneficial if the sites can retain information about past user actions via cookies or server-side methods and present information that's organized based on what interested the user previously. So you need to track it as well to organize the information and how the user actually search it. This can help less frequent users find what they need with minimal navigation. Since mobile web access is transient, mobile users are likely multitasking and have limited time and cognitive resources to get the information they seek. So it will minimize the navigation if you organize it on the most important in these websites as well. So since mobile web access is transient, mobile users are likely multitasking and have limited and cognitive resources to get the information they seek. Mobile versions of your site need to streamline navigation and eliminate verbiage, allowing users to rapidly find what they are looking for. Though you can use responsive techniques, be careful with navigation and information flow. Transaction website posture. This typically are structured in a hierarchical page-based manner similar to an informational website. But in addition to informational content, the pages contain functional elements with complex behaviors. So similar to website, but it has more complex behavior because the pages contain functional elements with complex behavior. In the case of the online store, these functional elements include the shopping cart, the checkout features, and the ability to save a user profile. Some shopping sites have more sophisticated and interactive tools, as well such as configurators, which allow users to customize or choose options related to their purchases. So some sites actually have sophisticated configurators that allows them to customize or choose options related to their purchase. So here, Amazon is the classic example of transactional e-commerce website. It was one of the first most successful of its kind. So in some cases, such as comparison shopping, they're also likely to bounce among several sites. But in some case, such as comparison shopping, they're also likely to bounce among several sites. For this type of sites, navigational clarity is very important, as are access to supporting information and efficient transaction. So navigational clarity is important here, as are access to supporting information and efficient transaction. So for comparison shopping, actually they also bounce in different sites. So for this type of sites such as Amazon or Shopee, navigational clarity is important, as are access to supporting information and efficient transactions. Search engines like Google, Search and Bing are a special kind of transactional site designed to provide navigation to other websites, as well as access to aggregated news and information from a variety of sources. So Google search and Bing are example of that allows you to access to aggregated news and information from a variety of sources. So the website complex transactional site example is Google and Bing. The transient aspect of user experience with transactional site makes it especially important that users not be forced to navigate more than necessary. It may be tempting to break informations and functions into several pages to reduce load time and visual complexity, both which are good objectives. User interface engineering conducted a landmark usability in 2001 of user perception of page load times for e-commerce sites. The result confirmed that user perception of load time is more closely correlated to whether the user can achieve his or her goals than to actual page load times. So the perception actually is more important than the actual load time, which will decide the perception on how it actually how the user achieve his goal. Kind of like in the perception principle in persona. Designing transactional websites requires attention to information architecture for content and page organization, and attention to interaction design for the creation of the appropriate behaviors for more functional elements. So it needs information architecture, which we discussed in the previous video, for content and page, and attention to interaction design for the functional elements, which we've discussed in the visual, the chapter 5, or the visual, the interaction, visual and designer, industrial design chapter. Visual design must serve both of these ends. It must also effectively communicate key brand attributes. So these are actually important in this complex website. So website application for posture. While some web applications maintain a page-based navigation models, these pages are more analogous to views than they are to web documents. So the web application, instead of pages or web documents, are more analogous to views. Kind of like in desktop application, technology now supports robust asynchronous communication with the server and local data caching. This allows an application delivered through a browser to behave in much the same way as a network desktop application. Here are some examples of web application. Enterprise software ranging from old school SAP interfaces duplicated in a browser to contemporary collaborative tools such as Salesforce.com and 37 Signal Basecamp. Personal publishing and sharing tools, including blogging software such as WordPress, photo sharing software such as Flickr, and cloud storage such as Dropbox. Productivity tools such as Zoho Docs and Google Docs. Social software such as Facebook and Google+. Web-based streaming media apps such as Zulu, Pandora, and RDIO. Web applications like these are presented to users very much like desktop applications that happen to run inside a browser window. They also can be employed for infrequently used functionality for which the user may not want to go to the trouble of installing a dedicated executable. In addition, it can be of significant value to allow people to effortlessly access the same data and functionality from the cloud, one of the core strengths of web applications. Sovereign web applications. Sovereign web applications strive to deliver information and functionality in a manner that best supports more complex human activities. Often this requires a rich and interactive user interface. Proto.io, an online interactive prototyping service, offers tasks such as drag and drop assembly of prototypes using a library of interactive objects and behavior specification tools, in-place editing for text labels, and other direct manipulation tools. Other examples of sovereign web applications include enterprise software and engineering tools such as Jira delivered through a browser. Designers also need a clear understanding of the medium's technical limitation and what the development organization can reasonably accomplish on time and within budget. Like sovereign desktop application, most sovereign web applications should be full-screen applications, densely populated with controls and data objects. So they also should make use of specialized panes or other screen regions to group related functions and objects. Users should have the feeling that they are in an environment, not that they are navigating from page to page or place to place. So redrawing, you want to avoid this the exercise as well in this page to page in web application. Redrawing and re-rendering information should be minimized as opposed to the behavior on websites where almost any action requires a full redraw. So you need to avoid redraw, instead provide this pop-up like in web application. So Proto.io's web-based interactive prototyping environment is as rich as refined as many desktop authoring environments, featuring drag and drop assembly and direct manipulation of all interactive objects. Transient web applications, whether it's a routine task that is performed only once a year to file taxes or the occasional generation of an ad hoc report, transient web application aim to accomplish just this. When designing transient web application, as with all transient applications, it is critical to provide clear orientation and navigation. So, a web application could have a transient as well because it could have a complex features, but the same principle is true. The orientation and the navigation of information is important. Also keep in mind that one user's transient application may be another user's sovereign application. So it's the same with sites as well. One user's sovereign application website could be another user's transient site. Think hard about how compatible the two users' needs are. An enterprise web application often serves a wide range of personas and require multiple user interfaces accessing the same set of information. So an enterprise web application often serves wide range of persona that could provide transient and sovereign to different people that access the same information. So you need to organize the information based on that. Posture for mobile devices. Since there's a new and exceptionally powerful mobile devices with high resolution displays and capacitive multi-touch input technology have become the mainstream platform of choice, converging functionality and integrating into people's lives like no interactive devices before them, which pose new challenges to designer with regards to posture. Smartphone and handheld posture. Functionally and posturally speaking, all the handheld, uh, even the best in class of this device, the Palm Trio, the direct descendant of the ground-breaking Palm Pilot, suffer from a small, low-resolution and rudimentary by current standards touchscreen. However, that all changed with the introduction of the iPhone and Android smartphones, which together heralded the dawn of a new era of a standalone on-the-go computing. Satellite posture. In the early days of mobile devices are seen only as satellite of desktop computer systems. Palm and early Windows mobile devices both succeeded best at portable extensions of the desktop geared primarily toward accessing and viewing information and providing only lightweight input and editing features. These devices were optimized for viewing or playing data loaded from desktop, and they included a means of syncing handheld data with desktop data. It uses as much of the limited screen real estate available on the device as possible to faithfully display content authored on or loaded from the desktop. Controls are limited to navigating and viewing data or documents. Some devices with satellite posture may have an on-screen keyboard, but these usually are small and are designed for brief and infrequent use. The convergence handheld device now dominated the market. Since the advent of the iPhone and its competitors, these have become tiny, full-fledged computers in their own right. However, satellite posture is the model for dedicated content-oriented devices such as digital cameras, highly portable dedicated e-readers like the e-ink Kindle, see figure 9.8, and what remains of the dedicated digital audio and video player market such as the iPad Mini. So here, before it's just a satellite posture, but now it become a full-fledged computer. So we won't be providing the figure for e-Kindle, but what used to be a satellite for just syncing in the cloud is now a full-fledged computer. So one new development for satellite devices is the advent of wearable computing. Wristwatch and eyeglasses format devices typically pair with a standalone convergent device via Bluetooth or other wireless connection and provide notification and other contextual information via small touchscreen or heads-up displays and voice commands. Standalone posture application shares some attributes with both sovereign and transient applications. Like sovereign applications, they are full screen and sport functional accessible via menus, often through left or right swipe gesture, and toolbars placed along the top or bottom of the screen. Also, like sovereign applications, standalone application can include transient model, dialog like screens or pop-up, most of which should be used to configure settings or confirm destructive actions. Like transient applications, standalone handheld application make relatively little use of comparatively larger controls and text due to limitation with legibility and finger-based input on multi-touch screens. Standalone apps for handling, like transient apps, need to be self-explanatory. The on-the-go nature of handheld app usage means that most people will use a variety of apps for relatively brief sessions over any given period of time. The telephone apps in modern smartphones also behave transiently. Users place their call as quickly as possible and then abandon the interface in favor of the conversation and on-phone carriers that support it other apps while the calls takes place. The best interface for a phone is arguably non-visual, especially when used in automobile. Voice activation such as that offered by Apple Siri or Google's Android OS is perfectly for placing a call. The more transient the phone's interface, the better. Tablet device posture. 7-inch tablet, especially those with the 16:9 aspect ratio such as Google Nexus 7 and Amazon Kindle Fire HD, live in an awkward dimensional space between smaller handheld form factors and larger tablets. List-oriented views are uncomfortably wide, while grid views with more than 2 rows or columns, depending on orientation, seem cramped. Designers should be sure not to treat 7-inch tablets like oversized phones when deciding their layout. Specific platform issues aside, tablets for the most part enforce the sovereign quality of their apps. The popular tablet operating system permit only full-screen application. These sovereign apps often have scrollable or zoomable main content views with top, bottom, or side toolbars or palette. So here, figure 9.10 Keynote for iPad is a sovereign posture iOS version of Apple's presentation software for the Mac. It has functions equivalent to its desktop cousin. So here, Adobe Sketchbook Pro is a drawing and painting app. On the iPad, it supports a zoomable main drawing area along with the toolbar and hideable tool palette on left and right. Android tablets supports the concept of widget, a transient posture micro apps that access the functionality of an installed sovereign app without it bringing into the foreground. Users may position these widgets on a special home screen for easy access to things like weather, stock reports, or music playback controls. Windows Surface, shown in figure 9.12, has similar concept called tiles. They can contain active content for an installed sovereign app but not controls, providing similar transient posture access to content only. Postures for other platforms. Kiosk posture. Kiosks exist for wayfinding in malls, purchasing tickets on public transportation, checking in at airports, self-checkout in grocery stores, and even ordering meals at some takeout restaurants. The large full-screen nature of kiosks would appear to bias them towards sovereign posture, but there are several reasons why the situation is not quite that simple. Most kiosks employ either touchscreens or bezel buttons to the side of the display, and neither of these input mechanisms supports the high data density you would expect of a sovereign application. Most kiosk users rarely are comfortable seated in front of an optimally placed monitor. The user behavior and constraint should bias most kiosks toward transient posture. With simple navigation, large, colorful, engaging interface with clear affordance for controls, and clear mappings between hardware controls, if any, and their corresponding software functions. As in the design of handhelds, floating windows and dialog should be avoided. Any such information or behavior is best integrated into a single, full screen as in sovereign posture application. Kiosk thus thread an interesting middle ground between the two most common desktop postures. Because transactional kiosks often guide users through a process or set of information screen by screen, contextual orientation and navigation are more important than global navigation. Rather than helping users understand where they are in the system, help them understand where they are in their process. It's also important for transactional kiosks to provide escape hatches that allow user to cancel transaction and start over at any point. Design principle, kiosks should be optimized for first-time users. 10-foot interface posture, in some way they resemble the satellite posture of content browsing mobile touchscreen applications. For instance, as in multi-touch mobile UIs, navigation typically is both horizontal and vertical, with content options organized into grids. And when filtering, with filtering and navigation options frequently available at the top or left. The primary difference is, of course, that of the touchscreen direct swipe and tap gestures and are replaced with five-way D-pad interaction of an infrared or Bluetooth remote control. In other aspect, this is a big difference. It introduces the need for a current focus item. Current focus need to be obvious in a 10-foot UI so that user always know where he is and where he can go next. The PlayStation 4 is a good example of how 10-foot UIs can use a layout similar to tablet UIs. Large button and simple left, right or up, down navigation with almost two columns is the norm. See figure 9.13. Seeing this screen out of context, you might believe it was from a multi-touch app. So here, figure 9.13, the PlayStation 4 UI bears more than passing semblance of a touchscreen tablet app, and for good reason. Despite the difference in input mechanism, navigation is rather similar between 10-foot UIs and many content browsing multi-touch tablet apps. Automotive interface posture. Unlike kiosk, users are seated but much similar to kiosk. Users typically attempt one relatively simple transaction at a time if they are also driving. Automotive interfaces, of course, have additional constraint that they must be of minimal destruction to the driver, since keeping control of the vehicle and avoiding harm are always the primary task. The transaction with the system is secondary at best. At the same time, the system should be available for focus use by a passenger if one is present. For entertainment, HVAC control and setting changes. Automotive interfaces are transient in the way we would expect. Large controls and simple screens. But navigation interface may take more of a sovereign stance. The interface will persist for the duration of the trip, which should be hours or even days. Most navigation systems remember their state even if the car has been turned off to get gas or park overnight at a hotel along the route. So automotive navigation interface focus on rich dynamic content. Map and current route information take center stage. A host of ancillary information is located in the periphery of the screen, such as the road's name, the time, the arrival time, the distance to the destination, the distance to the next line, and the direction of the next turn. Although this kind of information hierarchy is more typical of a sovereign posture interface, it must, in the case of an automotive system, be designed more like a transient UI, clear, simple, and readable at glance. It sports a Tesla sports a single 17-inch multi-touch screen. So this is an exception with adjustable panes for simultaneous navigation, entertainment, and HVAC controls. The interface resembles a tablet's interactive posture much more than it does a kiosk. If this is the new norm, so we hope new cars will also include active accident avoidance system to counteract any driver distraction that might occur as a result of such large information-rich interactive displays on the dashboard. So here, figure 9.14, the Tesla Model S infotainment interface is impressive in both its size and level of interactivity. Its 17-inch multi-touch screen allows navigation, entertainment, and HVAC function to be displayed simultaneously. This system bears more of a postural resemblance to a tablet than to a kiosk, as is more typical for automotive info system. Smart posture application interfaces usually are transient posture interfaces. Users of this interface are seldom technology savvy and therefore should be presented with the most simple and straightforward interface possible. These users are also accustomed to hardware controls. So here this Samsung washing machine has well designed color touchscreen display with a clear and simple navigational structure. Unless an unprecedented ease of use can be achieved with a touchscreen, dials and buttons are still a better choice. Instead of making things easier, simple LCD becomes confusing array of unworkable controls. Another reason for a transient stance in appliance interfaces that users of appliances need to accomplish something very specific. Like users of transactional kiosks, they are uninterested in exploring the interface or getting additional information. Give your apps good posture. In conclusion, it's important to remember that the top level patterns of posture and platform should be among the first decision to be made in design of an interactive product. So this is actually the decision we made in the industrial visual and interaction design. In our experience, many poorly designed products suffer from the failure to make this decision consciously at any point. Rather than diving directly into the details, take a step back and consider what technical platform and behavior posture will best meet the needs of your users and business. Also consider the possible implications of these decisions on detailed interactions.